You're not required to, but if you have access to it and would like to follow along, we're currently in the OneNote file of Modal Node System, MNS Presentation 1251, OneNote, negative over an octave, best method for scale degree interval system. We have our presentations here, which we plan on adding plenty more to shortly. Also noting, within this OneNote presentation, we could spend all of our time on the music theory side of things. However, we also have another presentation by a similar number and name where we build these tables in Excel, practicing our Excel skills, our music skills, and just table visualization all at the same time. Looking once again at our interval notation, which is our distance notation, and it's also our directionality notation, which is where the current system basically falls apart because it doesn't have a very good way to indicate directionality. In other words, the way the current intervals are basically structured are as though if you think of a note number line, we're always going infinitely to the right or up in pitch. Or if you think about a clock face, we're always going clockwise around the clock face. But obviously, in reality, directionality is a thing. We could go to the right, we could go backwards to the left. We could go clockwise around the clock face or racetrack, and counterclockwise around the clock face or racetrack. We've seen in prior presentations that when we start to go counterclockwise, the current interval system kind of falls apart. Now we're going to go counterclockwise past an interval counterclockwise, and the system was already falling apart, and now we're adding the other factor, the other dimension of going over an octave, which means it's going to even fall apart further. Think about how we can deal with that with the current tools that we have, and then we'll introduce the new tools with a measurement method, which would make more sense. Let's first remember our analogy, first remembering the mindset that we want in order to map out the fretboard. That being the fretboard is the territory like the globe, and it has 7 continent or destination locations like the globe, and it has 5 oceans, which we're going to say are the pass-through locations to get to the destination locations, which are analogous to the continents. Our head is above the fretboard, above this low or heavy E string, the one closest to the ceiling. As we look down on the fretboard, we notice that it rotates around like the planet rotates around. We give it 12 degrees of rotation, calling those the notes in the musical alphabet. We're typically working on the 4th degree of rotation, that being the collection of notes, the continents, if you will, that are organized through the 4th degree of rotation, the key of C. So that's the 7 notes. Once we note that, then I no longer want to name all of the notes on the fretboard, because that would be like naming all of the positions of the planet from the perspective of space as the planet is rotating around in a circle. No, what I want to do is identify the view of rotation. Then I want to name the continents based on that perspective, which is basically what the Nashville number system does. We're just adding now the actual modes. The Nashville number system is the modal system. So 1 is an Ionian, the 4 is the Lydian, the 3 is the Phrygian, the 6 is the Aeolian, and so forth. If we went from the 4 to the 5, C to C sharp to D sharp, the whole thing would shift forward like the continents going around in a circle. Therefore, all of the intervals are the same. So that's going to be our concept. Now, the problem, of course, is that the scale degree system, it kind of forces us out of looking at the system from a continent to continent location. It wants us to name every point as though the globe was spinning around, and I'm going to name every position from every point as it spins around in a circle. That's not the most efficient way to do it. Or it also wants us to rename the continents within the system, the 7 continents, based on which one we're starting from, which would be like making a new map quest every time I go from a different order of locations. You don't need to do that. So that means that as we're looking at the current interval system, we want to keep that in mind. Now, if I'm measuring my distance, remember that it's not as hard as a map, because I don't have to go left, I don't have to go right. It's a racetrack. I can go clockwise or I can go counterclockwise. And I can count it using 2 different measuring methods in principle. One would be continent by continent in our analogy. The other would be continent and ocean in our analogy. Now, if I go continent to continent, that's where the current system is messed up, because if I went from this 2, South Africa, to 3, 4, it would be 2 continents up, 1, 2 continents up, right? This is South America, but they want to make that the 1, so it's the 1, 2, 3. So notice those two methods are really using the same measurement tool. That would be like using a ruler, but you put the ruler on the first continent instead of after the first continent. They're both using the same measurement distances. They just messed up the first unit of measure, right? And so those are the two methods that we can use, or we can use the continents and the oceans. So that would be 1, 2, 3 up. So that's going to be the idea, but we can also go backwards. So if I go backwards, it would be 1, 2, 3, 4, 5, 6 modal half steps backwards, which you would think similarly, if I make that the 1 and go counterclockwise, it would be 1, 2, 3, 4, 5, 6, 7 backwards. Problem is that it became apparent that negative scale degrees don't work, because then you would have to rename all the scale degrees in negative order, and you can't easily transpose it to the positive scale degrees because you started on the wrong number, right? So when we go in the negative direction, it totally falls apart. So we saw that before. Now we're adding the added problem of, what if I imagine I'm going around the track and then to here? So instead of going 1, 2 back to here, I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9 back here, which would be the 10th scale degree in the negative direction. Well, we don't have scale degrees, right? So that becomes a problem, because normally what happens on these distances is they actually drop the units. They drop like the note names, and then they use the scale degrees, and the scale degrees are off by 1, right? So then they couldn't use the scale degrees going in the negative direction because they don't line up. You can't subtract 7 easily and get to the forward position. And so we have a problem going in the negative direction, and now we're going in the negative direction over an octave, which is usually indicated if you drop the note names by having what we call compound scale degrees, right? You would call that the negative 10th. If I was going forward, I would call it like a 10th, right? But now I'm going backwards, and we don't have scale degrees. So what's the solution to this using the current system? The solution is you need to say the notes for the distance, because that'll help you to identify how far back you're going. Let me show you what I mean. So we have this same situation here. We've got our notes. We pick the key of C, which if I start on the C, whole step, half step, whole step, whole step, whole step, half step. Here's the 7 notes in our musical alphabet that we're going to be using. And remember that we could have started that from any other note, and all of the distances would be the same relative to that position. So now we're saying, okay, all of our intervals going forward, if I was just going in a note number line left to right, there would only be 11 distances from the first point, from any point. That's fine. But you can also imagine that, remember, there's a note number line perspective and there's a racetrack perspective. In reality, those two things are combined, because what's happening is you have a spiral that's going upwards, which has directionality both up and down, or left and right, and it has a circular dimension to it. So we can't really envision that with our minds too easily, therefore we have to kind of like pick one. So if I go above 12, I have to indicate, that I went another octave up. Now again, you don't have to. Like if I say it's a major third, for example, then what does that mean? That usually means that it's going to be a 4-note away major third, as we can see up here, a 4-note away major third. But what if I go an octave up? It would be 4 plus 12. So you could use scale degrees if you're going in the clockwise direction. I could go from 7 and then 8, 9, 10. It would be a major 10th. So you have that scale degree notation, but most people don't actually do that, particularly on the guitar, because we want to see the similarities of where all the flavor of the major thirds are. So my recommendation is to say, well, let's keep using the major third like most people kind of do, and then actually say the distance. So it's a 4-note away plus an octave, or a 4-note away plus 12, or a 16-note away major third. That gives you the flavor of a major third, and it gives you the the actual distance instead of calling this a major tenth. Now, the reason a textbook doesn't do that is because they don't say the notes. They just drop the notes entirely. And if you drop the notes entirely, then if you just say it's a major third, you've lost the dimension of over an octave. That would be like if we have our planet analogy, time is that other dimension, right? So you have the locations left, right, and then time could be the next dimension. I won't get into that, but in any case,